Let's see new concept here, that is series summation, right? So for series summation, first of all, if any expression is given in sine inverse x, cos inverse x, cot inverse x, anything, so always we will try to convert into tan inverse x, right? After converting into tan inverse x, that's in that series we will find out nth term, that is also you can say tr term. So tr term will be in the form of tan inverse, some expression will be given there. So the same expression whatever is given there, we will try to convert that expression into a plus minus b, right? So like a minus b divided by 1 plus ab, we will try to convert in this form. After converting in this form, so we can directly write down tan inverse of a minus tan inverse b, right? So this term will become like you can say suppose vr, and this term will become vr minus 1, right? Minus here. So let's say some example also. Suppose we have a expression, that is suppose sine inverse 1 upon root 2 minus sine inverse root 2 minus 1 divided by root 6 and plus like this. This expression is given, and final expression is sine inverse root n minus 1 divided by n in root also. Let's take root also here. Root of n into n plus 1, right? This type of expression is given. So here we will try to find out nth term. So always you will get nth term in this format, right? So here tr is nth term is sine inverse root n minus 1 divided by n into n plus 1 over root. This is nth term. So again we will try to convert this into sine inverse x, and here either plus or minus, right? So if we convert in minus, then it will be very easy for us. So sine inverse into sine inverse y. We will try to convert this expression into sine inverse x minus sine inverse y. So what we can write down if we want to convert this into this expression, sine inverse x minus sine inverse y. So let's manipulate the question, sine inverse x. So if we write down like this, root n divided by root n into n plus 1, like root of n plus 1 minus n minus 1 divided by root of n into n plus 1, right? This is the expression. So again, if we convert this expression like this, see, sine inverse x into 1 minus y square minus y into 1 minus x square. So this expression we will convert in this format, right? So here we have to identify which term is x, which term is 1 minus root of 1 minus y square, right? So here sine inverse, if we consider this thing like 1 upon root n as x, and what is 1 minus 1 upon root n square of root over this, so this will become n minus 1 divided by root n, like this. So this is if this is x, then 1 minus x square root of this one is this one, that will be present here, because here you will get x times 1 minus y, here you will get x times 1 minus y square. Here we have to find out y times 1 minus x square, right? So we already got this term, that is x and y. Now we have to identify which term is working as x, sorry, y, not x. X already we got here. So suppose this is x, then definitely this term n upon n plus root of n upon 1, this term should be 1 minus y square. That means here there should be a term, that is y. So let's separate 1 minus x square of root. So if we separate this term, that means we have to separate n minus 1 divided by root n, it minus here. So except this one, we are getting here root of n plus 1, right? So this term is x and this term is 1 minus y square, this term is y, this is root of 1 minus x square, right? So directly we can write down this thing as sine inverse x, that is 1 upon root n, minus here sine inverse of y, y is here root n minus 1 divided by root n, this is the value of y. Right, this is our nth term, tn, this is our tn. So here it is given, this is first term, this one is first term, this one is second term, right? And like this we have, this is nth term. So here it is given summation of all these terms, right? This is, yes, summation of all these terms, this is plus here. So now what is the first term according to this tn? What is the first term? So the first term is sine inverse 1 upon, we have to put value of n as 1, so this will become 1 upon root n, that is 1, minus sine inverse root n minus 1. So value of n is 1 here, so we will get 0, n 1 minus 1 is 0, divided by 1. So what is the second term? So second term will be tan inverse 1 upon root 2 minus, and here this will become sine inverse, and this is 1 upon, here we are taking t equals to 2. So for t equals to 2 we will get, we have to take same, let me check once again. So this was x into 1 minus y square, this was 1 minus y square, right? So what is the value of 1 minus x square? So what was the value of 1 minus x square? So yes, this was the value of 1 upon x square, that means this term is 1 minus x square and this term is y. So here also we have to change. So nth term, in nth term this is sine inverse x and this is sine inverse y. So here this will become 1 upon root n plus 1. So here this will become 1 upon root n plus 1, that is root 2, right, minus root 2. So here t2 is 1 upon root 2 and here minus sine inverse of 1 upon root n plus 1, that is root 3. So what is t3? So t3 is sine inverse 1 upon root 3 minus sine inverse of 1 upon root 4, right, that is n plus 1, n is 3, that means here we will get root 4. So similarly, what is tn? Tn is sine inverse 1 upon root n minus sine inverse 1 upon n plus root n plus 1, right? So the question is find the sum of the series. So that means if we add first, second, third, fourth term simultaneously, so we will get sum of the series. So while adding, so what is going on here? So this 1 by root 2, this 1 by root 2, sine inverse 1 by root 2 will get cancelled out, right? Similarly this term and this term will get cancelled out. So like this, first term is remaining here, we are getting first term, at the end we will get second, this last term. So how much we are getting? Sum of all these terms from r equals to 1 to n is, we are getting this sine inverse 1, and at the end we are getting, see this term also will get cancelled out above this one term. So from this term and this term will get cancelled out, whatever terms will be there, so that will also get cancelled out. So here we are getting sine inverse, and this is 1 upon n plus 1, like this, okay, we will get this term. So up to, we have to find the number of sum up to, suppose up to infinity, right? Suppose n is also infinity. So this is sine inverse 1, that is pi by 2, pi by 2 minus, if n is approaching towards infinity, if n is approaching towards infinity, so 1 upon infinity plus 1, this will approach towards 0, so sine inverse 0, this sine inverse 0 will become 0, so that is 0. So we are getting pi by 2. Okay, so sum of this series is pi by 2. Sum is approaching towards pi by 2. So like this we can use the concept. Let's solve next problem based on same concept. Suppose the question is find the sum of the series 1 by 3 plus tan inverse 2 by 9 plus tan inverse 4 by 33, like this. So the last term, that is nth term of this series, is 2 raised to n minus 1 divided by 1 plus 2 raised to 2n minus 1, right, up to infinity. We need to find sum up to infinity, right? Again this is given in 10, so we will, and here nth term is, suppose tr term is 10, or also tn we can say here, tan inverse 2 raised to n minus 1 divided by 1 plus 2 raised to 2n minus 1. This is our nth term. So we will try to convert this nth term as tan inverse a minus tan inverse b, right? Or the formula tan inverse a minus b upon 1 plus ab. So again you can see 1 is already given here, so only we need to find the product of a into b here, and in numerator this should be a minus b, right? So if we write down this expression as tan inverse, this is something like 2 raised to n by 2. This is 2 raised to, this expression is 2 raised to n by 2. 2 raised to n minus 1 means 2 raised to n into 2 raised to minus 1. That 2 raised to minus 1 is 1 by 2, right? So this is something written as x by 2. So if I write down x by 2 as x minus x by 2, this is also equals to x by 2, right? So by these things, if we write down this expression as 2 raised to n minus 2 raised to n by 2, right? This is a minus b divided by, if you solve this, if you simplify this, you will get same, that is 2 raised to by 2. If you simply multiply this one, this will become 2 times 2 raised to n minus 2 raised to n. So this is equals to 2 raised to, this will become 2 raised to n by 2, right? Because already 2 also will be there. So 2 raised to 2 into 2 raised to n minus 2n is 2 raised to n, and divided by 2 also was there, right? So divided by here 1 plus 2 raised to n into 2 raised to n by 2. This expression also you can break it like this, right? Whole square is there, that means 2 raised to into 2 raised to n, both will be there, and this minus 1 means divided by 2. So that means we are able to convert this nth term into tan inverse a minus b divided by 1 plus ab. So that means we can write down nth term as tan inverse 2 raised to n minus tan inverse 2 raised to n minus 1, that is here 2 raised to n by 2, that is 2 raised to n minus 1. So this is our nth term. So by using this nth term, we can write down whole series here. So what is the first term of this series? That is here tan inverse 1 by 3. So that means if we put here n equals to 1, we will get first term of the series. So first term of the series is tan inverse 2 raised to 1 minus tan inverse, value of n is 1, so this will become 0. 1 minus 1, 0. So tan raised to 0 means 1. 2 raised to 0 means 1. And what is the second term? Second term is tan inverse, here put n equals to 2, so this will become 4 minus tan inverse, if we are taking 2 here, so this will become 2 only, right? Now write down third term, tan inverse 2 raised to 3, that is 8 minus, here this will become 2 raised to 2, that is 4, right? tan inverse 4. So like this we have to write down n terms, right? So Tn is equals to 10 raised to 2 raised to n minus 10 raised to 2 raised to n minus 1, right? Now add all these terms here. So as you can see here, this time this term, sorry, not this term, first term and the second term of this second term, that is second term of T2. There are two terms, first one and second. The second will get cancelled out. Second with first of T1 will get cancelled out, right? So again this first and this second will get cancelled out. So like this one, you can see here this term is remaining here. So similarly this term will get cancelled out by this term, right? So this term will get cancelled out by this term. So how much we will get at the end? So T sum of all these terms, that is summation r equals to 1 to n tr. So that is equals to here minus tan inverse 1, right, and here plus tan inverse 2 raised to n, right? So here tan inverse minus 1 is minus pi by 4, right? So plus, if again here, because n is up to infinity, so if n is approaching towards infinity, 2 raised to infinity will approach towards infinity. Tan is approaching towards infinity, that means its value will approach towards pi by 2. So pi by 2 minus pi by 4, that is equals to pi by 4. So overall pi by 4 is the answer. So the sum of the series is approaching towards pi by 4, right? This one. These questions are very important for advanced also, for mains also, right? You will get so many PYQs based on this question, suppose. Okay, so solve these questions up to here.